Welcome to module number 1. Hey, we're getting started in your journey on ethical hacking, and it's really fun. And we're going to be looking in this module just to add an overview, an introduction to ethical hacking. Let's have a look at some of the learning objectives that we will have for this module. We're going to start off with information security concepts. We're going to move into hacking concepts. We're going to look at explaining some of the ethical hacking concepts and scope. And then from there, we're going to look into hacking methodologies and frameworks, moving into a summarization of the techniques that are used in information security. And lastly, we're going to look at laws and their importance in ethical hacking. All right, let's start off with our first learning objective. Learning objective number 1, we're going to be looking at some security concepts. All right, let's have a look at the elements of information security. If you look at this, if you're familiar with some other security courses, some of this might remind you of the CIA. The CIA is a triad, a triangle of confidentiality, integrity, and authenticity. And we have a more comprehensive layout of this that's a little bit more than you would have with a little triad. So let's have a look at it here, and I have some questions for you. All right, so first of all, confidentiality. We're sending a message from person A to person B, and we don't want anybody to intercept it. What do you think might be a technology of confidentiality? And an answer to that might be AES, the Advanced Encryption Standard that we're going to talk about in Module 20. So that's a technology of confidentiality. Let's have a look at integrity. Integrity is not where if the message is intercepted, it cannot be broken into like confidentiality, but rather it is the idea that the message sent from A to B has not changed. Not even a single bit. So if you want to guarantee that happens, what's a technology that you could use to do that? And in this case, it's a hashing or a digital signature technology. So something like, for instance, SHA-256, which is the secure hashing algorithm, again, that we'll see in Module 20. All right, I have another question for you. Let's look at the next one down. That's availability. Availability is the idea that whatever resource you have, no matter what, will always stay online. So if one goes down, a portion of it goes down, you don't lose the whole thing. So what might be availability? Well, if you're in the cloud, a technology for availability might be redundant data centers. But if you're in the data center, it might be RAID or load balancing. What about authenticity? Authenticity is the idea that the entity, and let me just back off a little bit and tell you about when I use the word entity. When I say there's an entity, I'm not talking about a ghost. I'm talking about a user, a computer, a program, a process. It is something that's making use of the resource or the communication channel. And so since we don't know what it might be, we'll just call it an entity. So let's have a look again at this. So authenticity is the fact that an entity needs to access a resource, and we need to make sure we know who that is and verify that that entity is who they say they are. And so what might be a technology for authenticity? That might be something like Active Directory, if you're looking at a network. Or if you're looking at dev or programming, we're talking about something like OAuth. So there are many, many different types of tools that can help with authenticity. Let's look at the last one. The last one is non-repudiation. So let's say that I was to send an email to you, and somebody wanted to make sure that it was I who actually sent the email. And I can't say I didn't send it because there is non-repudiation that's involved. So in other words, with non-repudiation, the entity that originated the communication cannot repudiate the fact that they sent the information because their identity is tied to that communication. Can you think of some type of technology that non-repudiation might work with? You know, I really think like a PKI might provide all of the things, that's a public key infrastructure, that might provide all of the things we need for a non-repudiation. All right, so the next thing we want to look at is the idea of information security, motives, and goals. So if we look at motives and goals, an area that is sometimes surprising to people is the fact that you must have actually 3 different items, all 3 of them, for there to be an attack. Now, first of all, why would there be an attack? You've been around, you've listened to what's going on in the news, and you wouldn't be in this class if you didn't have some type of IT background, and you know that people attack in order to gain money. They attack to do a ransom. They attack because they are told to by a government. There are many reasons for cybersecurity attacks. But one thing that is required for every attack is this equation that you see right here. And that is, you have to have motive plus method plus vulnerability. Wait a minute. I love math. I'm a stickler for math. So I'm going to alter this equation to make it work a little bit better. Here we go. Boom. There we are. We put multiplication in between these because if one of them is 0, the entire equation is 0. What do I mean by that? Well, let's take one of the small businesses that I've worked with in the past. And in that small business, they asked me to come have a look at their network and help them with security and with their network. And I find that they're all sharing the same password in the entire small business. They have email with an open relay. They have resources like routers and switches with default settings like a web page displayed in HTML. They have IoT light bulbs that are on their network with open passwords. And I think to myself, how in the world has this organization not yet been hacked? Well, it's because of one small thing in this equation, and that is the motive. Nobody knows about it. And so we go to 0, there is no attack. So if you were to think about this, the motive, the method, and the vulnerability, you'd see this makes sense. All right, so now let's talk about TTPs. TTPs are tactics, techniques, and procedures. And when you look at TTPs, this is the way, the strategy of the tactic that is adopted by the attacker. The technique is the method that they use, and the procedure is their system, how they do it. You'll see that as we go through the CEH, you will develop TTPs. You will have tools that you prefer, methods that you prefer. And those tools and methods are how we can identify the thumbprint of the attacker. In fact, if you look at reports, and we're going to look at resources later on where you can find information about these attacks, they will give you the TTPs of the threat actor. Next thing we want to look at is the idea of a vulnerability. What in the world is a vulnerability? There are many reasons why there are vulnerabilities. The vulnerability is the hole in the system through which the attack happens. It could be because of default settings. It could be because the administrator or the user or the business owner made a mistake when they set up. Or it could be the application itself is not produced properly. Or it could be the operating system or the browser has issues. But either way, that vulnerability is the means through which the attack will occur. All right, now let's look at some types of attacks. The first thing we have here is a passive attack. And when we get into sniffing, we're going to talk about passive attacks. And this is where you're just gathering information and you are not interacting with the target of the attack. Just an example of a passive attack: if you are gathering information about the organization, just going online and looking up that information. Or if you are listening in through Wi-Fi, you're running a sniffer like Wireshark, and you're not sending packets in or making contact. Well, the next one down would be an active attack. An active attack is when you are sending information in or sending packets in. So an example of footprinting actively would be to call, for instance, the help desk. You call the help desk and you say, hello, I need to have my account password reset. And then you go through a spiel, then get them to create an account for you. That's active. Or when I use an attack tool to send packets in so I get a response back, that is also active. All right, so let's look a little bit further. The next thing we have is a close-in attack. So let's say that I am able to get in my car and sit right in the parking lot next to a window, and I'm right there in the network. Or maybe I work for the company. That would be an insider attack. Or maybe I do an attack where I gather hashes, and then I need to crack those hashes, and then I can use a distributed attack. Either way, what you need to realize, and I think you do, otherwise you wouldn't be here, is that we, meaning all of us, are in a constant state of information warfare, where we have attackers on one side and we have defenders on the other side. You know, one thing that I find very fascinating is when I am at a customer site and I'm looking at their edge network, their edge router, their edge firewall, and I see all of the collection of attacks that come in from all around the world. It is rather shocking, and it just goes on and on and on. And as the planet turns, you can see these coming in from various locations. All right, we're in learning objective number 2. And in this learning objective, we're going to look at some of the concepts in hacker classes. Let's get rolling. All right, so in learning objective number 2, we're going to start with what is hacking. So let me give you an overview of what hacking is. If you were to go to YouTube, are you familiar with that website? I know, it's kind of small. Maybe you never visited it. No, obviously YouTube is where a lot of us go. And if you were to do a search on the term hacks, H-A-C-K-S, guess what you would find? You would find hair hacks. So do you know if you mix peanut butter with coconut oil and rub it into, don't do that, but there are all these crazy videos on that. Car hacks. Do you know that if you do this to your tires or your engine, there are woodworking and house fixing hacks of various types. And of course, there are a lot of the hacks that we're talking about. So what does that mean? Hacking is the ability to take an extremely complex system and use it in a way for which it was not designed. So, for instance, in computer systems, the computer system was designed to communicate. But by running a certain series of steps, I can pull out all the user accounts from that system. That would be a hack. So we take a complex system and use it differently. The complex systems that we're talking about in this class are going to be operating systems, computers, applications, etc. All right, so who is a hacker? A hacker is somebody who has the skill and the knowledge to make use of these complex systems. They could do it as a hobby, which I do, and I use it also for work, or you can do it nefariously. And that is another reason why we're in this class, because we need to learn how illegal black hat hacker does their job, if we can call it a job, so that we can learn to defend against it. So we're going to learn the same tricks and skills. Now, there are many different hacker motivations. We see that we have the idea of script kiddies. So you're at work and everything's going fine. Your 12-year-old comes home from school and she's just so bored. And so what she does is she sits down at the computer and downloads a virtual machine that gives her all the hacking tools in the world. She watches a video and next thing you know, she's hacking away. That's a script kiddie. Inexperienced, often young, but not always. Any one of us watching the video or me can easily be a script kiddie, right? But we have other types of hackers too. But I want to focus on two major types of hackers. Number one is a white hat hacker, and number two is a black hat hacker. So starting with black hat hacker, that is somebody who is hacking for illegal purposes. A white hat hacker is what we want you to be, an ethical hacker who is a professional in cybersecurity, for instance. And there's a big difference between these two. Let's talk about that. What is the major difference between black hat and white hat hackers? You know what that is? One word. That is permission. And that is the dividing line between all these different classes and categories of hackers. One more I want to focus on, and that would be the idea of a gray hat hacker. And for those of you who've taken previous versions of the CEH, the definition has changed to match more of the industry standard, and that is somebody who hacks with permission, perhaps during the day, but at night or another time, they hack without permission. So they have the traits of a black hat and a white hat. If you look at the rest of these, we have hacktivism and state-sponsored hackers. I remember where was I? I was at Quantico, and I was teaching a course in the EC Council Storm device to some ethical hackers at Quantico. And I was going through some of this stuff, and I went to the idea of a state-sponsored hacker, and I told them, hey, you guys are state-sponsored hackers. And we all laughed about that, but that was pretty cool. But there are many other types, from blue hat to red hat and so on. I'll leave it to you to have a look at the differences in this table. In this learning objective, we're going to have a look at ethical hacking, its concepts, and the scope of ethical hacking. So what is ethical hacking? Ethical hacking is when we take all of the techniques that a black hat hacker would use to crack into a network and into applications, etc., and we use those for the benefits of our client. So with ethical hacking, we are looking at those vulnerabilities and exposures, and we're exposing them and we're hacking them for the benefit of our client. It is necessary because of several things. Let's have a look. Number one, we want to take those techniques, run through our organization's applications, installations, and operating systems, and assess those systems and determine if there are vulnerabilities and expose them so we can help our organization. We also want to be able to take those vulnerabilities, turn them into a report with remediations that the organization can use so they can go forward. Also, many organizations are required by law to have this type of work done, so it's important that they retain people like you and me to get this work done. Okay, so what about the scope and limitations of ethical hacking? Well, let's start with the scope. The scope is the limits of ethical hacking. It might be that an ethical hacker is just retained to do security auditing, helping audit different portions, or maybe just retained to run some type of program on a specific subnet. Whatever it is, whether it's just risk management, you have to be very careful to stay within the scope of ethical hacking. In fact, in our CPENT course, which is the course after the CEH, we talk about that quite a lot when we're creating that report. Or the next thing we want to look at is the limitations of ethical hacking. And there are limits. Number one, we may have predefined objectives, and we want to make sure that the business that we're dealing with understands the objectives that we have, and our objectives work with what they're doing. And then not only that, but the business, the organization, needs to actually understand the implementation and remediation advice that we give them. So if I am retained to work on ethical hacking for an organization, and I give them recommendations and they don't even understand what I'm talking about, it's not going to be very helpful for them. So we have both scope and limitations to think about with ethical hacking. All right, the next thing we look at then is the skills of an ethical hacker. You are going to run into this throughout the entire course. So first of all, let's have a look at the other side, the left side of this slide. And this is a very important one right here, which is in-depth knowledge of Windows, Unix, Linux, Mac. And it's not just the operating systems we're talking about, applications. So for instance, programming in C# or programming in C++, or in many other languages that we'll talk about when we get into our module on hacking applications. Also, the ability to understand RDBMSs, a relational database management system, like Microsoft SQL Server or MySQL. Also, going beyond that, everything from small devices like phones and mobile devices like tablets to Android and so on. The more you know, the better you will be at ethical hacking. So having this high technical knowledge is very important. And I want to assure you that you can gain the levels of technical knowledge that you require. All right, the next thing, let's look at the other side of this, that you need as an ethical hacker is the ability to learn. I'm going to add to this, which is not just the ability to learn, but the desire to learn. And the fact that you are here right now shows me that you have the desire to learn. There are two types of people who work with computers. I like to talk about this because it's very interesting. We have one type of person working with computers, and after they get back from work, they're like, you know what? I work at computers all day. When I get home, I just want to relax with some Netflix and a glass of wine and not touch a computer the rest of the evening. And the other type of person says, I work with computers all day. When I get home, I just want to program my Raspberry Pi and automate my home systems. And they talk about all the stuff they want to do because they keep wanting to work more of technology. If you're like person B, then you are going to do great in this class. So also, an ethical hacker needs to be committed to two major areas too. Let's talk about those. The two major areas of commitment that you are going to need is commitment to the law. Because if you take the skills that we're going to be talking about and you use them illegally, you're going to be in big trouble. But not just the law. Let's scale it down a little bit. You also need to be committed to your organization's own systems and rules and so on, so that you won't take this class, module 3 or whatever, and then go back to your office and hack away at your office. No, you can't do that. So we have to be committed to not only the laws, but our policies and standards of the workplace. All right, so this class is really cool. I keep saying that, but one of the things that I really like about it is it's highly AI driven. We are in a new era, aren't we? How many times have you had the opportunity to interact with the various levels of AI in the world? It's pretty amazing. And what we see is the black hat hackers, the people that are out there taking down our networks and our apps, they are using AI. And they're doing AI-driven attacks. So it is extremely important that you and I know how to do AI-driven attacks. In this class, we're going to be all over AI. Let's have a look at what we're going to be doing. So it's a modern approach to security. It helps with emerging threats. One of the things that is important to understand is we are in a highly exponential area of human technological change. And that may not mean a lot to you, but if you open up a tab right now and look at the article in Wikipedia, I think it will be fine, on the singularity. And you know what I'm talking about. All that might not be 100% true what they say in there, but it talks about that exponential curve of change. One of the biggest problems in our mind is we don't think exponentially, we think linearly. And so it's hard for us to anticipate the changes that happen so quickly. So what I tell all my students, and I tell all of the customers that I work with, that if you are not using AI daily to accelerate what you are doing, you are already behind the curve. So that's why we have it integrated so much into what we're doing with the CEH. So what you'll see is we're going to be using AI to help with efficacy, with accuracy, with scalability, with cost effectiveness. So AI is extremely important, and you're going to see us use this over and over again. In fact, if we look at the AI-driven ethical hacking and how it helps us, let's just have a look at these points here. Number one, automation of repetitive tasks. Oh man, this has been so helpful in hacking, because with hacking, you have a huge iterative burden. What do I mean by iterative burden? Sometimes it takes going through a series of maybe 20 or 30 steps over and over and over again, dozens of times, and it takes a long time. If you can automate it, it is quite wonderful. Next thing we look at is predictive analysis, where we can take the AI and we can say, hey AI, show me where this might be going. Advanced threat detection, where I can have, for instance, on my SIM, where I'm collecting all my logs for my organization, I can have an AI look at thousands, tens of thousands of logs, and then predict where things are going, whereas it might take me years to pour through 10,000 logs. Next thing we look at then is enhanced decision making. That would be about the same as the one before that. Adaptive learning, where we can adapt to the environment, adapt to different types of attacks. Enhanced reporting. If you've ever used a large language model, or LLM, like ChatGPT, or one of the co-pilots, or Grok, or Perplexity AI, and asked it to create a report for you out of data, it is amazing what you could do with that. We'll be looking at that. Simulation and testing, scalability, continuous monitoring, adaptive defense measures, all of these, as we'll see as we get deeper into the class, are endemic. They're part of what makes AI so amazing. All right, so what about AI? It's going to replace ethical hackers? Are we out of a job? Sadly, yes. And that is the end of the course. No, obviously no. We have a lot more to go. And no, it's not going to replace ethical hackers, because what it's going to help us do is automate. It's going to help us dynamically adjust to hacking situations. It's going to help us take the deep learning knowledge that AI has gained and use it for our own ends, our own desires. And it's going to help us by automating those tasks like I was talking about a little bit earlier. All right, so let's have a look at what we're going to be doing with AI in terms of the CEH. We're going to be using an extremely flexible and powerful tool called Shell GPT. Shell GPT can run on Windows, Shell GPT can run on Linux, on your Mac. We're going to be using it from the lab. I'm going to show examples in it. And what it does is it ties back in to the API that you would normally have with ChatGPT out of OpenAI, and it brings it to your desktop so that you can use regular natural language to allow the ChatGPT API to make use of local tools to do a hack. Okay, so let's have a look at what actually happens here. So we can see here that we're doing sudo su, which is going to allow us to run as an administrator. And then you go down here and we're going to be using SGPT. And we're going to see in the labs that there are a variety of parameters that we can feed it. And then in between quotes, we put the natural language that we want to use. So there are a variety of other AI-driven hacking tools that you see at the bottom of slides, like Hack GPT, Pentest GPT, Bug Hunt GPT, Make GPT, Ethical Hacker GPT, and there are a lot more. And what I also will be doing throughout the course is supplementing the slides with a little bit of extra information that can help you with AI and many other things. So for instance, right here, what I want to emphasize is LLM acceleration. And I grabbed this from an LLM. This is analysis, right? So we can take data sets. So for instance, let's say that you're at a customer, you've just been engaged to help with some ethical hacking, and you go to their Edge network and you download say a few megabytes of logs, and you can use an API to examine those logs. Also, we have scripting and coding. There is a series that I do that maybe for different companies that ask for it and so on, called Future Hacks. And in my Future Hacks series, I talk about near-term and slightly long-term technologies and how they will affect the cybersecurity environment. And one of them that I did, I think about a year and a half ago, was a ScriptKitty AI-based attack. And so what I had a demonstration of is somebody who knows nothing about programming at all, able to use an LLM to create novel executables, novel binaries, novel scripts that could potentially be very dangerous to the network. All right, also, what about Black Hat LLM acceleration? So Black Hats, people who are attacking and stealing information, are using this for sophisticated phishing. We'll talk about that when we get to that section. And generating novel binaries and scripts too. Black Hat hackers are doing that. So what we want to do is make use of those solutions that they're doing and use them for defense. Like for instance, detection and response and continuous learning and adaptation. So we have a lot that we can learn from the use of AI and make use of in our day-to-day hacking. Okay, so in this learning objective, we're going to look at methodologies and frameworks for hacking. Let's start off with a look at the ethical hacking framework upon which this class is mostly based. I mentioned earlier the 5 phases of ethical hacking, starting with reconnaissance, moving into vulnerability scanning, moving into gaining, and then maintaining, and then covering tracks. So let me go look over here and focus in on this a little bit. There we go with footprinting and reconnaissance. That's our next module. Here we go with scanning and enumeration. That's the model after that. And then we go to vulnerability analysis. And then right after that, we jump into hacking systems. And we're going to be there for a while. You see some of the tools that we'll be using, Wireshark and Metasploit and Burp Suite, etc. And then you go down here and we have TTPs like password cracking, etc. We're going to be doing all of that. Look right down here at the bottom, hacking AI. That's a very fun section that we'll be also getting into, hacking with AI. Next thing we'll look at is an extremely important tool also that the CEH is also mapped into, and that is this cyber kill chain. When we talk about the cyber kill chain, there are many different steps. And the cyber kill chain, when you break the chain at a given step, then you stop the hack. All right, so here's what's going to happen. There is an evil hacker from a country that you may know. The evil hacker lives in a country called Kevministan. Yes, and the evil hacker's name is Linda. Linda from Kevministan wants to attack the company CEH Corp. So what Linda does is she scans LinkedIn, making use of the LinkedIn API to pull down information about the CEH Corp employees. Sure enough, there are CEH Corp employees that post information and projects on LinkedIn. There are many of them. She chooses several of them based upon a cross-reference that she does for those accounts in Facebook. And she finds 2 accounts in Facebook that do all kinds of posts and interaction on Facebook. And she finds that both of those employees have hobbies. What hobbies do they have? Oh, I know. One likes to do knitting. Yes, this person is a knitting fanatic. And the other, let's come up with a hobby. Oh, golf. The other one likes to play a lot of golf, and they're on different golf courses all over the city, the state, and the country. So now that Linda, let's look over here in this slide, she has done her reconnaissance. Now, after getting information on the network from LinkedIn, she knows what types of operating systems and databases and application infrastructure that they're running. So she crafts a binary, an executable that would work on that. Okay, so now what does Linda do? Well, what Linda's going to do is she's going to set up her own Facebook pages. She's going to use AI and bots to help accelerate the growth of the Facebook pages until they have enough people in them that it looks like it's been around for a while. Now she's going to send an invite to both of those employees, one all about knitting, the other all about golf, with the crafted binaries that she has as part of that. When those employees click on that, wow, we go to the next section, which is exploitation. So with exploitation, there's going to be code that begins to run on this network. And that code is, oh no, it made it. It is actually running. It's installing on that workstation. Oh, hey, fortunately, you have your Certified Ethical Hacker certification, and they have just asked you to do a first run on the network, and you told them that they need to have some type of network protection. And so when the binary runs on the network and tries to make communication back channels to the command and control services that Linda has set up in the cloud in her country of Kevministan, all of a sudden there's an alert and it is stopped. So where did we break it? We broke the chain at command and control. And so the actions on objectives do not happen. So isn't that cool? If we can break it anywhere, I would prefer that in network defense we break it at the beginning at reconnaissance, where we tell our employees to be very careful what they put online. All right, let's talk about the MITRE ATT&CK framework. The MITRE ATT&CK framework is actually very similar to what we were seeing before with the cyber kill chain. They're both designed to understand and address cyber attacks and helps to break them down into their TTPs. The MITRE ATT&CK framework, though, is based more firmly on current attack strategies and current TTPs that threat actors are using. All right, there's another very nice tool called the Diamond Model of Intrusion. If you are working in an organization and you are working in IH&R, incident handling and response, and you get a ticket that there's a binary running on somebody's system, we want to know a few things about that binary. By the way, for those of you who don't understand what I mean by binary, a binary is just an executable. It's a program that runs. We use that often when referring to programs in Linux. So with this binary, it's running on the system. How did it get there? Who sent it? How did it get clicked on, or how is it running on that system? So we can look at the adversary that sent it. We can look at the capability. We can look at the victim. Oh, how were they chosen? How did it get there? And what infrastructure is it running on? Is it a Mac that it's running on? Is it running through the network? Is there a port that's open? We put all these together and we can get a very good idea of what's happening when there is an intrusion on a system. Okay, so now we're going to get into a section on the idea of techniques that we use for information security controls. And I talk about this a lot when we do network defense, but I will say this, that controls, if you want to understand what controls are, think of Control-Alt-Delete. If you use a Windows computer system and you want to gain access to resources, before you can, you have to do a Control-Alt-Delete. So a control is some type of system or item that's put into place to moderate or mediate access to a resource. So it's something that stands in between the user or the requester and the resource. With that in mind, let's jump into this section looking at security controls. First thing we look at is the idea of information assurance. With information assurance, let's just actually have a look at the definition on this slide because it kind of lays it out for you. It is the assurance in the integrity, availability, confidentiality, and authenticity, what we just looked at, of an information system that's protected, that's going to be that control, during the use, processing, storage, or transmission. So that's a pretty comprehensive definition. Let's have a look at some of the items that we're going to be dealing with information assurance. We start off with policies. In fact, the most important item of network defense is policy. Everything shakes out from policy. Because if I have a policy, let's say a password policy, and let's say the password policy is 8 characters, that you have to have a password of 8 characters. Can you imagine how that would affect routers, switches, cloud workloads, IoT? Everything would be negatively affected by that policy. So that policy is where we start. All right, let's go over here and have a look at some of the others. So we have network authentication, authorization, network vulnerability identification, problem and resource requirements, plans for resource requirements, appropriate information assurance, there's that word again, controls, and performing certification and accreditation. Some of that is what you would be doing as an ethical hacker. And then lastly is providing information assurance training. Hey, that's what I'm doing. So these are some of the things we look at with information assurance. Next, let's have a look at this idea of a continuously adaptive strategy. So what we want to do is make sure that we are always changing as the security environment changes. We start with protecting the organization. And the core of that protection is assets. Now, I am going to make a spelling correction on this slide and an upcoming slide. The spelling correction, I want you to look at that triangle in the middle where it says ASSETS. You know what? You need to replace all of those S's with dollar signs. Yeah, that's right, dollar signs. Because when we rank what's most important in an organization, it is ranked by how much it will cost us if something bad happens to it. So that's why we replace them with dollar signs. So that the core of what we are protecting, the core of what we are detecting, responding to, and predicting is those assets. And so we surround those assets with administrative, physical, and technological operations, people that we engage to help with this, and those technologies. So, but this is all on a continuous wheel. Now, I'm going to give you some advice that I'm going to repeat many times throughout this class, and that is to be on the lookout for certain areas where you might be tested on the exam. Anytime you see a life cycle or something like this where it's listed from 1 through 4, be prepared to put it in order on the exam. So if you are asked a question, for instance, Fred is protecting data, what part of the continual adaptive life cycle is he in? And that is in the protect section. Next thing we look at very quickly is defense in depth. If you look at all these different layers in defense in depth, this is where we have network defense, starting with procedures and policies, moving through physical, which is very important, so that you can't just walk into the data center and walk out with a server that you just stole. That actually happened to one of my clients. Perimeter, then we go into internal network, host, application and data. So if you look at all these concentric circles, we have a variety of controls at each level to secure in depth. Next, we look at another word that I'd like to re-spell. We're going to spell this with a $sign. Why? Because the most important risk is the one that costs our company the most. Let's say, for instance, that there is some type of exploit that, if it hits our company, will cost us $1 million an hour. Well, that is the one I need to focus on the most. So if you look at the upper right-hand corner of this chart, we are going to be looking at an extreme risk. And guess which ones we're going to focus on? We're going to focus on those first. All right, let's have a look at risk management. If there is an extreme risk, what are we going to do? We are going to treat the risk. What is risk treatment? Well, that means that we're going to do some type of action that gives us a control over that risk. So let's say that it was a web server. That might cost us $1 million a day if it goes down. So I might want to put a web application firewall in front of that web server. I might want to remediate the components of that web server. What I want to do is mitigate that risk. All right, the next thing we look at then is cyber threat intelligence. What is CTI? CTI is a way that we can gather information about potential threats so that we can not only take action in the future, but take action in the present. Let's have a look at some of these categories. The first one, strategic. Whenever I think of strategic, I think of a general, and maybe during World War II, and there's a little pit and they're pushing around troops with a long stick or something like that, and they're taking these troop movements of hundreds or thousands of troops and over an entire continent, and they are making these plans. Then if you go down to the bottom right-hand corner, we look at technical, and this is sort of like when a small platoon is making a plan to combat an enemy that they can actually see on the ground. So strategic, let's say right now there's an example of global cybersecurity trends. And this is given to an upper level manager. Let's say the idea of quantum computers being brought online in the near future. And so we're going to plan to defend against that. Moving all the way down to technical, where there is actually TTPs, or I should say IOCs, indicators of compromise of an attack right now happening on the network or on the system or for an app. And we're responding to that right now. All right, so let's have a look at a life cycle. Hey, I gave you warning. I said that you want to be prepared on the exam to put together life cycles back in their appropriate order. This is a threat intelligence life cycle, starting with planning, moving through collection, moving in there into processing, exploitation, and analysis and production. And we also end with dissemination and integration. And so for each one of these, what we're doing is we are collecting information, we are processing it, we're disseminating it to other entities, we are incorporating it, meaning that, for instance, if I find out that there is a specific threat, I connect with an organization that can give me the IOCs, the indicators of compromise for that threat. Let's say one of those IOCs is an IP address from a threat actor, and I can take that IP address and incorporate it into my edge network or into my endpoint protection and stop the threat from being an attack. Okay, so now let's have a look at threat modeling. What I want to do with threat modeling is I want to take threat assessment a little bit deeper and put together a simulation as to what would happen if certain threats are realized on our software, hardware, networks, operating systems. So let's have a look at some of the areas that we deal with threat modeling. So with threat modeling, we start off with identifying security objectives. And this is actually very important. This is part of the planning area where we are going to put together the landscape that we need for the following steps. And then we're going to look at the components, how data flows. This is where you might have DFDs. If you're not familiar with data flow diagrams, they're actually very interesting, showing how information flows through an organization, an application, items like that. Then we decompose it into detailed threats at every different level, identifying those threats. And then what we want to do is find out what weaknesses we currently have that might make those threats turn out to be an attack. All right, so next thing we want to have a look at then is incident management. Have you ever worked for an organization where you get a ticket? No, I don't mean that you get pulled over by the police. I mean that you have your phone or you're on your desktop or laptop and there's a little pop-up that says you've been sent a ticket that you need to pursue. Like for instance, there might be an incident that occurred and you're part of the team that works on that incident. That's incident management. So it's got a ticketing system. You have various levels of your organization involved in it. And so you might be one that's doing triage or analysis or so on. Just very quickly, we have 9 stages in incident handling and response, starting with preparation. With preparation, do you actually have an IH&R, incident handling and response system? Well, we might need to build it. But either way, we're going to assign tickets. And number 2, we're going to triage it. If I'm working for a large organization, it is possible that there are dozens or scores of tickets that I receive. I need to make sure the most important ones get handled first and then send out notifications to interested parties, stakeholders. And then I get to containment. With containment, I'm not solving anything. I am stopping the threat from spreading. So for instance, let's say there's a binary running on a workstation. I want to isolate that workstation so it doesn't spread to other workstations, but I want to keep the binary running because I'm going to go to my forensics team, which we see in the next step, and pull forensic information, TTPs, pull IOCs from that, find out exactly how and why it happened. Once I have all that information, I can begin to act against that threat and go to the next step, which is number 7, eradication. Eradication, and the keywords for eradication are root cause. I want to get rid of the root cause. So let's say that the reason that the attack happened is because my policy was to set the password to at least 8 characters. Well, that root cause is the policy, and then I'll need to change the policy immediately. Or it could be an open port or a component in a web server or a web app, whatever it is. We need to get rid of that root cause, plug it up, then we get to recovery. And the key word from that section is to restore from backup. And then we have some post-incident activities like documentation and updating policy, etc., and reporting that we'll need to do. All right, so now let's have a look at the role of AI and ML. AI, artificial intelligence, ML, machine learning. And this is a way of taking artificial intelligence, computing, et cetera, and using it in cybersecurity. So if you have a look at this, we have 2 major areas for artificial learning, machine learning, et cetera, unsupervised and supervised. And normally what we're going to be dealing with in this class is unsupervised learning, because we're going to be making use of GPTs, transformer models, et cetera, that help us with large language models. And we're going to be interfacing with the large language models. And so they're less guided than, for instance, other types of AI where we have supervised learning. All right, so we also want to find out how this helps us prevent cyber attacks. I think we kind of covered this a little bit, but wow, I mean, we can use AI to help us with passwords, with phishing detection, phishing attacks. So not just detections, but attacks, threat detection, vulnerability management, finding vulnerabilities, helping us in attacking vulnerabilities. And then from there, we go to behavioral analytics. This is going to be the behavior of the attacker, behavior of employees, et cetera. Moving there from network security. We have a lot of antivirus solutions that have AI in the back end. It's part of how they work, detecting frauds, detecting botnets, and then AI that can help us combat threats. So there's quite a lot with AI. All right, so I want to show you some stuff that I put together to tell you a little bit more about AI. Check this out. I want to talk a little bit about the role of generative AI in LLMs in cybersecurity. We're going to be using that quite a lot using SGPT and other tools in our labs and in the demonstrations that you'll see on our slides. But you can also just go directly to the LLM, for instance, ChatGPT or Perplexity AI or GitHub Copilot. If you're using GitHub and you have a paid account, you can make use of Copilot. In fact, a huge majority of code written today is written and accelerated through Copilot. Then we have Google Gemini, and by the time you watch this, some of these might have changed in terms of logos, but I think you know what I'm talking about. So this is generative AI. This is AI that can create new content based upon a huge amount of content it's already trained on using models like transformer models. Then we look at AI communities, for instance, Hugging Face. If you've never been to Hugging Face, open up a tab right now and do a search at DuckDuckGo or something like that and find Hugging Face. It is a collection of open source AI models that you can download and make use of right now. In fact, one of them that I use a tool that I use quite often is this one called LM Studio. If you want to run an open source AI model on your own system right now, you could download and make use of LM Studio. This is one of the larger models out there, and there are many others that will take its place over time. This is Mistral 7B, 7 billion parameter model that is extremely useful if you have a lot of compute and memory on your laptop or your desktop, and you can run through something like LM Studio. We have Llama. It's that kind of a chat GPT. You can take a lot of these things and have an interface right on your hacking computer or on your desktop that you can query just like you would ChatGPT or Microsoft's Copilot. It makes it very easy right there at your fingerprints to come up with novel ways of doing attacks, etc. Just one quick example of how I've made use of some of these tools. And sometimes I'm flying across the country. I have my laptop open and I do not have internet access because I'm not going to pay the $5 to get on the internet in the jet. So what I do is open up my local model and I can converse with it, create presentations, answer questions that I'm going to put in items that I'm writing, etc., without ever getting online. It's all local. This next section is on an area that affects us all, and that is the importance and application of security laws and standards. So whatever you're dealing with, you are in a country, you are in a state or province, you are in a city, you are in an organization that is affected by law. For example, you may be in an organization that processes credit cards. So you'll be affected by PCI DSS for credit card processing, having to build that secure network and make sure you defend cardholder data. Make sure that you are running a good vulnerability management program or access control measures. And guess what? You're going to be checked up on periodically to make sure you are in compliance. We also have a lot of ISO/IEC standards that are very important. The most important standard set, as you see here, if you look through all of these, what do you see on the far left side? ISO/IEC 27001. And so there are some that apply to things like information security management. The second one down is going to be privacy information management systems. And you can look through all of these. There are many different ISO/IEC standards that might affect your organization. You may be in an organization that is working on making sure that they're in compliance with a lot of these standards. If you work, I was working with an organization that you may be familiar with, And that organization is the VA, the Veterans Administration. And they run hospitals all over the United States, America. And so they are going to be dealing with patient data, patient records. You're going to be responsible for safeguarding those records and that patient's data. Next thing we look at then is the idea of SOX. So with SOX, what is SOX? SOX are the thing you put on your feet that often disappear in the dryer. No, in this case, it's Sarbanes-Oxley. What is Sarbanes-Oxley? It is a law that was put together after a specific company, actually a couple of companies, took a bunch of shareholders down. Are you familiar with the company? Yeah, it's called Enron. I remember it. And so this is to help with people who are investors in that organization and protect those investors by making sure that there is public accountability for boards and auditing and corporate responsibility and many other things, as you see as all of these titles of the Sarbanes-Oxley Act. Next thing we look at is a couple different ones. The one on the left that you see is the DCMA, and the one on the right that you see is FISMA. The DCMA is the Digital Millennium, and I put emphasis on that, Copyright Act. The reason I put emphasis on millennium, I call this the Napster Act. So what happened around the turn of the century, mid-90s, we have a technology called CSS that was there to sort of encrypt the information in a CD. And pretty soon, it was determined that we could take the information from a CD or a DVD and just rip it off that little disk and make it in digital form, and it could be transmitted anywhere on the internet. And the focus of all that was the company Napster. And eventually laws were passed as the entertainment industry and related industries realized that some of their materials could get loose. Well, actually all of them. And so that was put together for that. FISMA is put together for federal employees, federal contractors, and so on for the United States federal government. You have to comply with FISMA. All right, so what about GDPR? Well, there was a giant race, a time when everybody was working really hard to make sure they were compliant by the end of the date that was set off in 2018. And you had to be compliant by then, or else you'd be cut off from the EU. And that was GDPR. I remember that race to make sure everybody was compliant by then. The main thing about GDPR that had to be complied with by May 25th, 2018, this is a privacy and security policy. And a lot of organizations and people refer to this as the right to be forgotten. So for instance, let's say that I posted a video of myself ripping off my shirt and yelling really loud, and I don't want that on the internet anymore. So I contact the provider and I said, can you please get rid of that video of me ripping off my shirt and yelling real loud? And because of GDPR, they have a legal responsibility to get rid of that. Now, I'll say this though, is that it's probably everywhere else already anyway, but I can be forgotten. Also, the UK passed a similar law. It's just about the same, but it's for the UK in 2018 called the Data Protection Act. Okay, so look at this. The United States, look at all these laws we have. In fact, that is the sum total of all the laws in the United States. Obviously, we have a lot more than that. We have tens of millions of laws in the United States, and a lot of them actually deal with cybersecurity, information storage, etc. And if you're in another country and you're dealing with the United States, you have to have a look at the laws that you're dealing with. If I'm in the United States and I'm dealing with Australia, the United Kingdom, China, India, or Germany, or any other country in the world, I need to be aware of the laws that I am working with in order to make sure that I do not get banned in those countries. We also have many other countries, Italy, Japan, South Korea, Belgium. So we could go on and on. But either way, as an organization, I need to make sure that all of the work that I'm doing, it, depending on how it impinges on other nations, that I'm aware of how that work will interact with those laws. Okay, so wow, we just talked about a lot of stuff. This is all introductory. One of the things that I always need to do in this module is hold back and not get into too much depth, because some of the slides are based off of entire classes that I teach. But we did it. We talked about several things, talked about elements of security, talked about the MITRE ATT&CK framework, CEH, and the kill chain, talked about items in terms of risk management and threat intelligence, and we even went into some security acts. The next thing we're going to be looking at is our first actual hacking module, which is going to be module 2, which we're going to be going into footprinting. So it's going to be fun. And what I'd like you to do is join me in the lab. So what we're going to do in the lab is we're going to go over how you prepare your lab setup so that you can make use of the AI acceleration tools that we're going to be using in the lab. So we'll talk about that when you join me in the labs as we get set up for module 1.